Hi everyone! In this video, let us study derivatives. But first, let us define derivatives and why do we have this area in mathematics. So derivative is defined as the exact rate at which one quantity changes with respect to another. And derivative was being applied in finding the rate of heat flow in geology. It is also being applied in finding the rate of improvement of performance in psychology and in rate of the spread of humor in sociology. With the definition of derivatives, slope was being associated in this area because in slope, any change in y is also change in x. A perfect example for this is the flow rate in liters per minute. So as the tank increases its volume by x squared, what will be the flow rate in liters per minute? So that means any change in time will also be change in volume. Therefore, as the flow rate increases, the tank fills up faster and faster. And with a flow rate of 2x, the tank fills up at x squared. And this is where we got the idea of derivatives. So we have here constant rule and power rule. Function x is equal to c or constant, then f prime of x is equal to 0. And if function x is equal to x, then f prime of x is equal to 1. And if f of x is equal to x squared, then f prime of x is equal to 2x. If f of x is equal to x cubed, then f prime of x is equal to 3x squared. And if f of x is equal to x raised to 4, then f prime of x is equal to 4x cubed. But are we going to memorize all of this, constant and power rule? Fortunately, we have derivative of x raised to n with respect to x is equal to n times x raised to n minus 1. So using this theorem, we will be able to find the derivative of a function. Let us take an example. In our first example, we have f of x is equal to x plus 2 squared minus 1. So if we are going to simplify this term, that is equal to x squared plus 4x plus 4, and then minus 1. And simplifying these terms, that is equal to x squared plus 4x plus 3. Now we will use our theorem in finding the derivative. The derivative of x raised to n with respect to x is equal to n times x raised to n minus 1. So based from our theorem, we will multiply the exponent in the coefficient of our x. So that is 2 times 1, that is 2. And then we will subtract 1 from the exponent. So that is simply x. And in this term, we will multiply 1 from 4. So that is 4. And we will subtract 1 from the exponent. So mari-remove na yung x. Any number raised to 0 is equal to 1. So 1 times 4, that is simply 4. And then since this is constant, in our rule, we will just cancel it out. So our final answer is 2x plus 4. In our next example, for the derivative of our function x is equal to 8x times x minus 6. Simplifying this, so that is equal to 8x squared minus 48x. And if we will get its derivative using the theorem, we will multiply the exponent to the coefficient of x. So 2 times 8, that is 16. And we will subtract 1 from the exponent. So that will become x raised to 1 or simply x. And then in our second term, we will multiply the exponent of our variable x. That is 1 times 48 is 48. And then if we will subtract 1 from the exponent of our x, so that will become x raised to 0. And any number or variable raised to 0 is equal to 1. So 1 times 48 is simply 48. So our final answer now is 16x minus 48. So in our next example, we have f of x is equal to 3x cubed minus 6x plus 24. Since it was already simplified, then we will just get its derivative. So the derivative of 3x cubed minus 6x plus 24. So we're going to multiply the exponent 3 to the coefficient of the x, which is 3. So that is 9x, and then subtract 1 from the exponent. So that is 9x squared minus, so since the exponent of our x here is 1, we will multiply it by 6, so that is 6. But since this is 1 and we have to subtract 1 from the exponent, so that means 0. And any number or variable raised to 0 is always equal to 1. So 6 times 1 is just 6. And then since 24 is constant, then we will disregard 24. So this is now our final answer. So that's all, and thank you for watching. So now it's your turn to find the derivatives of the following. You may take a screenshot and answer this on a piece of paper. Thank you.